Greetings. My name is Tanish Patel and I am a third year EHTC student from DJ Savi College of Engineering. The rest of my teammates are Varun Chaudhary, Soham Shenoy, and Swayam Muslim. This is our video submission for Encore 1.2 Pre-Qualifier Challenge. Problem statement for the challenge is to design and simulate a buck converter based on the following parameters. Based on the parameters and the design equations for a buck converter, to derive the following values, the calculations for which can be found below. From the values of L critical and L ripple, we decided a value of 50 microhenry for inductor and a capacitor of 18.2 picofarads. For the MOSFET switch and diode, we've taken a voltage rating of greater than 24 volts, which is the input voltage, and a current rating of greater than 5 amps, which is the peak current. Moving on to LT Spice for simulation. Here is the schematic of the circuit that we've made. It is a standard DC buck converter based on non-isolated topology. For the switching, we use two MOSFETs along with an IC555. So the way this works is that whenever the IC555 sends in high, the following MOSFET acts as a closed switch and the gate for this MOSFET gets connected to the ground. Hence the following MOSFET is an open switch. Whenever the IC555 sends a low, the following MOSFET acts as a closed open switch and thus the gate for this MOSFET gets connected to the input voltage through a resistor. So basically the PWM generated from this terminal has a duty cycle that is the inverse of the PWM generated from the IC555. For example, if I want to generate a PWM of 20% duty cycle from here, I would generate a PWM from the IC555 with a duty cycle of 80%. Let's move on to the simulation now and run this. If we zoom in on this, we can see the voltage from this terminal, which is a PWM of the given duty cycle. In the below plot pane, we can see the current across the inductor rising and falling linearly corresponding to the PWM generated. The current through the load resistor R1 gives us the output current. The average output current that the simulation is showing is 4.35 amps. The below plot pane shows us the output voltage. The average value for the output voltage is 5 volts. If we go back to our original calculations, we have an output current of 4.32 amps and a desired output voltage of 5 volts, which matches our simulated values. Thank you.